Today, we're going to be solving quadratics by factoring. So obviously, before we get going, it would make sense to review at least one factoring problem. So pause your video now and please try the Ignite at the top of the page. Answer is up. So remember, now you could have chosen to do this by factor by grouping, but remember, usually when there's an a value of 1, you don't need to make it as complicated as that. Simply this one, it's really just what's going to multiply to give you a negative 12 that adds to give me a negative 1. So we usually start by finding all the factors of 12. So all the factors of 12, you should have had 1 and 12, 2 and 6, 3 and negative 3 and 4. But signs then are what really come into play, because this is obviously a negative 12. So in order to get a negative 12 by multiplying, that tells you that one of your numbers had to be negative, because a negative times a positive is a negative. And you really look at the middle term. You're looking for which of those combos add to give you a negative 1. So the reason why 3 and negative 4 works is because if I put the negative with the 4, 3 plus negative 4 gives me negative 1. And that's what determines what our final answer is going to be. Okay. Now today, don't worry, you're in luck, because we are going to start off by, today we're still factoring, but we are going to be solving by factoring. And solving happens, you'll probably notice kind of pretty much all from yesterday, that none of the problems that we worked with, they all looked kind of like this, in the sense that there wasn't an equal sign in there. If there's no equal sign, it's really just a matter of the only thing you can do is factor. If you're going to solve each quadratic by factoring, though, obviously that first step is still true. Now, x squared minus x minus 12, that was this problem up here. So we actually already solved this one technically. This factors into x plus 3 times x minus 4. Now, because that equals 0 is there, though, that means that we can actually go about solving this. You didn't solve it. All you did was factor it at this point. In order to solve, we use something called the zero product property, the ZZP. The zero product, ooh, ZPP, wow. Can't, ZPP. And this means the zero product property. And what the zero product property says is that if you take two things, i.e. in this one times this one, if you take two factors and multiply them together to equal 0, what that tells you is that either one of those numbers has to be 0. If I take two numbers, hypothetically anywhere in the world, and they equal 0, well, that means that either this number has to be 0, or this one has to be 0, or hypothetically both. But in factoring world, what it means we're looking for what number would make each of my factors 0. So what we do is whenever we get our two factors, in order to actually do the solve by factoring step, we split them apart. We say, okay, well, what is going to make x plus 3 equal to 0? Well, we're going to subtract 3 from both sides. And that means that x could equal negative 3. Same thing with x minus 4. Here we would solve for x. I would add 4 to both sides, and we get x equals positive 4. Wow, that 4 was really creepy, but definitely supposed to be a 4. Now, could you check your answer and plug them back in? Sure. If I take 4 squared, we get 16. Minus 4, we get 12. Minus 12, we get 0. So we know this guy works. If I plug in negative 3 times negative 3 is 9. 9 minus negative 3 is really 9 plus 3, which is 12. Minus 12, we also get 0. So just like all other solving problems, you should be able to plug them back in and see if they actually make it 0. But when you solve quadratics, you should have a solution for every individual factor. Now, sometimes you might be in luck where, like, if I look at number 2, you have to ask yourself, okay, well, is it factored yet? This one, your hint is yes. If I have my two sets of parentheses, two things currently being multiplied, I did all the factoring for you. You just have to do the solving. So in the first one, I'm going to add 4 to both sides. We're going to get x equals 4. Second one, I'm going to subtract 11 from both sides, and we're going to get x equals negative 11. Boom. Okay. Now, We do have to be careful though, and especially like if you, I'm going to do one more actually, number 3. So like this one, especially it looks a little bit odd when we're missing that 0x, like that middle x term that's normally in between the squared term and the number. Usually my first step is I usually always go through and add it myself, because we still have to go through and factor this. We still have to say, okay, well, what times what gives me x squared? Well, that has to be x times x. To fill in the kind of the 2 blanks that are in the problem though, this is where we have to look at the problem. So we have to say, well, what's gonna multiply to give me the last term? So I always start with, again, the last number, and I find all the factors. We could do 1 times 25, or the only other set of factors actually is 5 times 5. And your hint as to what it's gonna be is they have to add to give me 0. And the only way to make that happen, to get a negative 25 and to add to be 0, is make one of the numbers negative. 1 and 25 can't possibly get you to 0. That either gets you to 26 or 24, so that's out. So we resort to negative 5 and 5. And we are factored. Now don't get caught up in the slump and be like, Ms. Hardy, I'm done. No, you did not solve. You factored, you didn't actually solve it. The solving step means take each of those steps, take each of those factors, and set them equal to 0. So we add 5 to both sides on this one, we get x equals 5. This one I'm going to subtract 5 to both sides, and we're going to get x equals negative 5. All right. Now, number 4. This one I will do with you guys just because this is a little bit different. And you're going to notice that we're actually missing the number. But one thing that Miss Hardy was really bad at checking on all of them, and you're all in luck because there was no GCF, but you have to make sure, remember that we always check for GCF first. Now I didn't do it first on the other 3 because the GCF on all of those was 1, but GCF on this one is not 1. Ooh, I wrote 1, but it's not 1. We look at the numbers on this side and we say, okay, let's start with just the number. We have both 15 and 12. The largest number that goes into both of those is 3. And let's look at variables. This has 2 x's, this has 1 x. You can take, they both have at least 1 x in common. So GCF ends up being 3x. That is going to be what I'm going to filter out. Divide them both by 3x. We're going to be allowed, the GCF goes on the outside, the leftovers go back on the inside. 15 divided by 3 ends up being 5. It had 2 x's, but you're taking 1 out, so you're left with 1. And over here, negative 12 divided by 3 ends up being a negative 4. And x divided by x cancels, so you are left with 5x minus 4. Now again, kind of a hint that you would go to guess and check. Usually that's from the step where we have the squared involved. But we don't have a squared piece on something like this. That once you're down to your 2 factors and there's no more squareds in the problems, that's kind of your hint. That is your hint that you are done, at least with the factoring aspect. We still have to go through and solve. So here I had a GCF. The GCF is treated like any other factor. We still take it, we set it equal to 0. I'm going to take the other factor, which is 5x minus 4. And I'm going to set that guy equal to 0. And both of these I'm going to solve. So the first one I'm going to divide by 3. 0 divided by 3 is 0. On the second one here, I'm going to add 4 to both sides. We're going to be left with 5x equals 4. And if I divide by 5, doesn't turn out to be the nicest, but we get x equals 4/5. And there we go. Now, there is kind of one catch to go along with this. Whenever we solve by factoring, we really have to make sure not only that we check the GCF first, but with solving, there is a step that actually comes before GCF. And that is set equal to 0. Everything that we're doing, you cannot do unless the problem is set equal to 0. So like number 5, I had a warning sign on this one because I don't want it to be equal to -5. I can really only use my property if it's equal to 0. So my first step is I'm going to add it over to the other side. And I'm going to kind of place it where it's supposed to go. So my number is supposed to go on the end. So I'm supposed to be x squared plus 6x plus 5 equals 0. And now we're right back where we were at in the rest of the problems. So what I want you to do, I'm actually going to pause this one. I want you to continue example 5 and try number 6 before we move on. All right, answers are up. You should have gone on number 5. Final answers were x equals -5 or x equals -1. Something to keep note of when it comes to finding the solutions for these, please make sure you include the variable. If you just say solutions are -5 or -1, technically that's not correct. I'm looking for, you have to actually state, we're solving for the variable in the problem. So if you don't put x equals on this or b equals or whatever variable is in here, you're missing the part of the solution essentially. All right. Now, if you look at the next page, when it comes to finding something called zeros, this is actually a common word. When we say find the zeros, just so you guys are aware, it means find the solutions. All right. A lot of times when we say find the zeros, we're gonna go through, there's a lot of words that really mean the same thing. There's a lot of words that mean find the solutions. Zeros is just one of them. I'm gonna throw more at you later on in the year, but for right now, if I say find the zeros, it just means find the solutions. And it means you just have to plug in 0 yourself. So like number 7, number 8, both of these guys, you're gonna plug in 0 for either y, or you're gonna plug it in this case, it's gonna become f of x. And both of these guys, we are going to factor and solve. Number 7, I'm gonna write out the answer on in just a minute. I'm gonna do number 8, just because this one is a little bit more involved, especially because of the fact that since a does not equal 1, that means this is a case where we're gonna involve grouping on this one. So I always start by, and I always do this kind of off to the side, we start by taking the a term and multiplying it by the b term. So I'm gonna do 3 times -12, and we are gonna get -36. And what I'm gonna do is I'm gonna start by finding all the factors of 36. So we could do 1 and 36. There's a lot of them here. Sorry about this. 2 and 18. You could do 3 and 12. You could do 4 and 9. And last but not least, you could do 6 and 6. Now, just like all the other problems though, you're gonna say, okay, well, what numbers multiply to give me -36? That also add to give me 5. Well, if they have to multiply to be a -36, that tells me that I need a sign of each. And the only way I could ever get to 5 is by using 4 and 9. If I make 4 negative, -4 times 9 is -36, and -4 plus 9 ends up being 5. So what that tells us is that's going to be what I replace my middle term with. So I'm going to take instead of writing a 5x, we're going to put a -4x and then a plus 9x. These guys, we put an x with them and they become part of our problem. Now, the whole idea of factoring by grouping now is we actually have to do the grouping step. And we group the first 2 together and we group the second 2 together. Now, if you had flipped these, if you had a 9x first and a -4x second, that is totally fine. It honestly doesn't matter which way you go. What matters is you do the grouping, the GCF part correctly. So on these first 2 terms, let's see, what's the largest number or variable that goes into both of these guys? Well, the only thing that goes into both is x. And leftovers are gonna go back inside. So here it had 2 x's, we took 1 out, we're left with 3x. Here it had an x, we took it out, we are just left with -4. And now I'm gonna do the exact same thing with the second set. Here I'm gonna look for what's the largest number that goes into both 9 and 12. Well, answer for that is gonna be 3. And leftovers are gonna go back inside. 9 divided by 3 ends up being 3, bring the x down. -12, woo, that was fun. -12 divided by 3 ends up being -4. And here's your check. If you pause and you actually, oh, that was fun. Oh, I wanted, wow, guys. If you pause and look at what things are inside, those are your final answers. Those, not your final answers, but those should match. So If they don't match, that means that you did something wrong in the factoring by grouping. And last but not least is the step is to pull it out. These guys become its own quantity, and the ones outside become your other pair. And now you can solve. Now, in order, we did the factoring part. Now it's a matter of taking each of these guys and setting them equal to 0 and solving. This one's the easiest. I'll do that one first. One of your answers could be -3. On the first one, though, if I add 4 to both sides, we're left with 3x equals 4. Divide by 3, divide by 3. Final answer for the first equation that we wrote, it's for x equals 4/3. So there are your two answers. If you would like to pause your video and you want to try number 7, you may do so right now. Answer for number 7 is up. Now, number 7, this is actually a classic example of you don't always have to have two solutions. In this case, we do end up having two factors. This guy, I don't need to solve by grouping unless you really want to. Since the A value on this one is 1, I just simply said, okay, what multiplies to give me 100? That adds to give me 20. So the answer to that question is 10 and 10. Now here, if you get two of the same exact quantities, you don't have to solve both of them twice. It's just a matter of saying x plus 10 equals 0 and solving. So final answer, it's just simply x equals -10. So now's a perfect time if you want to give the two you try nows at the bottom a try. We will go over these in class. If you do have any questions, though, you guys know the drill. Reach out, say hi to Miss Hardy, and set up a meeting. All right, guys, have a fabulous day.